Is a nearby supernova about to disrupt life on Earth? Elon Musk thinks so. From the moment humans first gazed up at the stars, we've been both mesmerized and humbled by their brilliance. They are ancient, enigmatic, and vast, silent witnesses to cosmic dramas unfolding on a scale that's nearly incomprehensible. One of these stellar giants, Betelgeuse, is once again at the center of a whirlwind of speculation, headlines, and scientific intrigue. And this time, it comes with a warning, issued by none other than Elon Musk. According to the tech mogul, Betelgeuse, a massive red supergiant located roughly 640 light-years away in the Orion constellation, is showing signs that it might soon explode into a supernova. Not centuries from now. Not millennia. But possibly within weeks. Musk's bold statement sent shockwaves through both the scientific community and the public, not only for the prediction itself but also for what it could mean for Earth. If Betelgeuse were to go supernova, Musk suggests that the resulting wave of high-energy radiation could reach Earth and cause disruptions, particularly in regions like New York, New Jersey, and Connecticut. Could a dying star really pose a threat to life on our planet from hundreds of light-years away? At first glance, the idea seems exaggerated, maybe even alarmist. But when Elon Musk speaks, especially about existential risks, the world listens. This isn't the first time Musk has issued grand-scale warnings. From AI taking over the world to the need for humans to colonize Mars to escape potential extinction events, he's known for projecting scenarios that blur the lines between science fiction and real possibility. But what makes his latest claim so intriguing is that Betelgeuse is no stranger to astrophysical concern. In fact, it's long been on scientists' watch lists as one of the most likely candidates in our galactic neighborhood to explode. So what do we know about Betelgeuse, and how realistic are Musk's warnings? To start, Betelgeuse is enormous, truly staggering in size. It's estimated to be about 700 to 1,000 times the diameter of our Sun. If you replaced our Sun with Betelgeuse, its outer edge would extend past the orbit of Jupiter. Its mass and size place it in a category known as red supergiants, stars that live fast and die young by astronomical standards. These giants burn through their nuclear fuel quickly, fusing hydrogen into helium, then progressively heavier elements like carbon, neon, and silicon. But when they start producing iron in their cores, the end is near. Fusion of iron does not release energy, it consumes it, causing the star to lose the delicate balance between outward pressure and inward gravity. In a flash, the core collapses, and the outer layers are expelled in a catastrophic explosion, a supernova. Supernovae are among the most violent and luminous events in the universe. They can briefly outshine entire galaxies and are responsible for dispersing heavy elements, like gold, uranium, and platinum, into space, seeding future generations of stars and planets. Without supernovae, many of the essential elements that make life possible, including those in our own bodies, would not exist. Astronomers have long believed that Betelgeuse is approaching this inevitable fate. But exactly when remains uncertain. Soon, in cosmic terms, could mean tomorrow, or 100,000 years from now. However, something unusual happened recently that reignited the conversation. In late 2019 and early 2020, Betelgeuse began to dim dramatically. Within weeks, its brightness dropped by nearly 40%. Stargazers around the world noticed. Was this a prelude to the star's imminent explosion? Speculation surged. Media outlets ran stories. Forums buzzed with theories. Even professional astronomers were puzzled. A star of Betelgeuse's prominence and stability isn't expected to behave like that. Eventually, after months of study, the dimming was attributed to a massive expulsion of material from the star's surface. That material cooled, condensed into dust, and temporarily blocked some of the light traveling toward Earth. But even if the cause wasn't a pre-supernova collapse, the event served as a powerful reminder. Betelgeuse is not a stable star. It is aging. It is active. And yes, it is dying. Now, Elon Musk's claim has brought Betelgeuse back into the global spotlight. According to him, the star could go supernova within weeks, And he warns the effects on Earth might not be as benign as many scientists suggest. He highlights the potential for a surge of radiation, particularly gamma rays and cosmic rays, which could have ripple effects on Earth's upper atmosphere and technology infrastructure. But is this claim rooted in science, or is it another case of speculative futurism? Theoretical physicist Dr. Michio Kaku, one of the most well-known voices in science communication, has weighed in. He agrees that Betelgeuse is indeed a ticking time bomb in the sky. Its collapse is inevitable. However, Kaku and most of the astrophysical community emphasize that a supernova within weeks is highly unlikely. Statistically, it's improbable to the extreme. Still, Kaku acknowledges that if a gamma-ray burst were to be directed straight at Earth, it could cause real damage, though the odds of that happening are vanishingly small. Let's talk about gamma-ray bursts, or GRBs. These are the most energetic explosions in the universe, capable of releasing in seconds more energy than the Sun will emit in its entire 10 billion-year lifetime. A GRB pointed directly at Earth from a relatively nearby source could indeed strip away part of our ozone layer, exposing life to harmful ultraviolet radiation. This could damage ecosystems, increase rates of skin cancer, and even alter global climate. However, there's a crucial detail about Betelgeuse. It's not likely to produce a gamma-ray burst. GRBs are typically associated with rapidly spinning massive stars collapsing into black holes, not slowly rotating red supergiants like Betelgeuse. Moreover, its rotational axis doesn't appear to be aimed at Earth. So, even if it somehow generated a GRB, the beam would likely shoot harmlessly into another region of the galaxy. The more likely, and far more fascinating, scenario is this. When Betelgeuse finally goes supernova, we won't experience chaos. We'll experience wonder. The explosion could light up the night sky, becoming as bright as a full moon and even visible in daylight. It might shine for weeks or months, outshining every other star in the sky. It would be a once-in-a-lifetime spectacle, and a goldmine for astronomers. The last time humans witnessed a similar event was in 1604, when Johannes Kepler documented a bright, new star in the night sky, a supernova that remained visible for almost a year. Even earlier, in 1054, Chinese astronomers recorded an event that gave rise to the Crab Nebula. In the 21st century, with space telescopes, radio arrays, and advanced spectrographs, we would observe Betelgeuse's death from every possible angle, learning more in weeks than we've learned in decades about stellar evolution, shockwaves, neutrino bursts, and element formation. And yet, Musk's warning raises a deeper issue. Even if this particular star won't destroy our way of life, we live in an age where our civilization is deeply entangled with space. Our power grids, GPS, communication networks, and weather forecasting systems depend on satellites orbiting high above Earth. High-energy space weather, from solar flares to galactic radiation, can affect those systems. In 1989, for example, a geomagnetic storm caused by a solar coronal mass ejection knocked out power across Quebec, plunging millions into darkness. If radiation from a nearby supernova were to interact with Earth's magnetic field, it could, in theory, trigger similar regional disruptions. So even if the odds are low, the question remains: are we ready for cosmic threats? Musk's message may sound dramatic, but perhaps it's a necessary provocation. It reminds us to ask hard questions. Are we doing enough to monitor the skies? Do we have backup systems in place to protect our technology from space-based events? Are we investing in early warning systems not just for asteroids, but for high-energy phenomena like GRBs and supernovae? Astronomers will continue to watch Betelgeuse closely. Observatories across the globe are tracking its light spectrum, mass fluctuations, and surface behavior. Satellites are watching for neutrino emissions, early indicators of a core collapse. We don't know exactly when the supernova will occur. But we do know this: when it does, it will be one of the most dramatic astronomical events ever witnessed by humanity. Whether the countdown is in days, decades, or millennia, Betelgeuse serves as a powerful cosmic reminder. The universe is not static. It's evolving. Stars are born, live, and die, shaping the very fabric of galaxies. Their final acts may be violent, but they are also the architects of everything we know. Even life. So as we wait, we watch. We stay curious. We stay ready. Because in the grand theater of the cosmos, Betelgeuse is nearing its final curtain call. And when the moment comes, the whole world will be looking up. This is Discovery at 2.0, where the cosmos isn't just distant, it's personal.